A 10 kilogram block is attached to a 20 kilogram pulley, which is a solid disc of radius 2 meters. The block is released from rest, causing the disc to spin. What is the angular acceleration of the disc? And how fast is the block falling after 8 seconds? So how can we calculate the angular acceleration of the disc? What do we need to do? Well, let's identify the forces that are in play here. So let's say that capital M represents the mass of the disc, and lowercase m, I'm not sure how that happened, but lowercase m represents the mass of the block. Now the block experiences a downward weight force of mg, and there's an upward tension force that slows down the descent of the block. And that tension force also causes the disc to spin in the clockwise direction. So with this information, how can we use it to calculate the angular acceleration? Now I'm going to describe T as being Ft, so that's the tension force, so I don't confuse that with torque. So what we can do at this point is write an expression for the net torque acting on the disc. Now there's only one force acting on the disc, which is the tension force. And torque is force times the moment arm, which in this case is the radius of the circle. So the net torque acting on the solid disc is the tension force multiplied by the radius of the circle. Now let's focus on the net force on a block. By the way, the disc is held in place. So the disc is allowed to spin, but it can't accelerate upward or downward. Only the block can accelerate downward. So we have to deal with the net force of the block. So the net force in the y direction of the block, it's based on these two forces. So we have an upward tension force, so it's going to be positive because it's directed in a positive y direction, plus the downward weight force, which is negative since it's going in a negative y direction. Now the net force, based on Newton's second law, is mass times acceleration. So let's solve for the tension force. Let's move this term to that side. So ma plus mg, where a is in the y direction, that's going to be equal to the tension force. Now here's a question for you. ma, should it be positive or negative? Because the block is accelerating in the negative y direction, it's going down, we need to put a negative in front of it. So we could say that the tension force is equal to positive mg minus ma. So now at this point, what I'm going to do is replace the tension force in this equation with mg minus ma. So the net torque acting on a disc is going to be mg minus ma times the radius. So now, since I'm running out of space, let's erase a few things. Now the acceleration, or rather the linear acceleration, is equal to the angular acceleration times the radius. So let's replace a with alpha times r. So the net torque is now mg minus m alpha times r. So what I'm going to do now is distribute r to these two terms. And at the same time, I'm going to replace the net torque with inertia times alpha, based on Newton's second law for rotational motion. So that's equal to mgr minus m alpha times r squared. Now my goal is to calculate the angular acceleration, so I need to isolate this term. So what I'm going to do now is take this term, move it to the left side. So inertia times alpha plus m alpha r squared is equal to mgr. Now this is the net torque acting on the disc. So this is the inertia of the disc. So right now let's factor out alpha. So what we're going to have is alpha multiplied by the inertia of the disc plus mr squared and that's equal to mgr. So for this particular problem, the angular acceleration can be calculated by taking the mass of the block, multiplying by the gravitational acceleration times the radius of the disk, divided by the inertia of the disk, plus mr squared, where lowercase m is the mass of the block. So now let's go ahead and calculate alpha. So that's going to be a mass of 10 times the gravitational acceleration of 9.8. The radius of the disk is 2 meters. Now I represents the inertia, and the inertia of a solid disk is 1/2 mr squared. So the mass of the disk is 20, and the radius is 2. So half of 20 is 10, and 10 times 2 squared is 40. So the inertia of the disk is 40, plus mr squared, which is going to be 10 times r squared, which is 2 squared. So 10 times 9.8 is 98, multiplied by 2, so that's 196. 10 times 2 squared is 40, plus another 40, that's going to be 80. So alpha is 196 divided by 80. And so that's going to be 2.45 radians per second squared. And so that's how you can calculate the angular acceleration of the disk. So that's how fast it's accelerating in this direction. Now what about part B? How fast is the block falling after 8 seconds? So how can we find that answer? Well, the first thing we need to do is calculate the linear acceleration of the disk. If we could find that, then we could find out the acceleration of the block as it falls down, because they have to be the same, because they're attached to a rope. And so they're going to move at the same rate. The linear acceleration of the disk is alpha times r. So we have alpha, which is 2.45, and the radius of the circle or the disk is 2 meters. So 2.45 times 2 is 4.9. So the linear acceleration of the system is 4.9 meters per second squared. And so that's the acceleration of the block as it descends down. So now we could find the final speed of the block as it falls for 8 seconds. So the final speed is going to be the initial speed plus AT. The initial speed is 0 because the block was released from rest, and the linear acceleration is 4.9 multiplied by 8. So 4.9 times 8 is 39.2 meters per second. So that's the speed of the block after 8 seconds. Now, if we wanted to find the velocity of the block, this would have to be negative. The acceleration technically is negative for the block because it's accelerating in a negative y direction. And so the velocity is negative 39.2 meters per second after 8 seconds. Now let's say if you wanted to find the distance at which the block fell for these 8 seconds, what would you do? So once you have alpha, and once you have the final speed, you can easily find the distance at which the object fell. So you can use this equation. V final squared is equal to V initial squared plus 2AD. So you know the final speed is 39.2. Once you square it, the negative sign doesn't matter. The initial speed is 0, and you have the linear acceleration, which is 4.9. So now you can find D, the vertical displacement of the object. So it's 39.2 squared, which is 1536.64, and 2 times 4.9 is 9.8. So take 1536.64 and divide it by 9.8. And so D is 156.8 meters. So that's how far the object fell, meaning the block. That's how far it fell after 8 seconds. So consider this problem. We have a 5 kilogram mass attached to a 20 kilogram pulley, which is a solid disc, and let's say the radius of the pulley is 3 meters. and that's attached to a hanging mass of 10 kilograms. Now once the system is released from rest, we know the system is going to accelerate in this direction. How can we calculate the acceleration of the entire system? So if you want to try this problem, feel free to do so and see if you can get the right answer. Pause the video if you want to try it. So I'm going to show you two ways in which to get the answer. A quick and simple way, and also a step-by-step procedure if you want to write out all the equations. So here's the quick and simple way to find the acceleration. Based on Newton's second law, the acceleration of the system is the net force acting on the system divided by the total mass of the system. So the only force that's really driving the system to motion is really the weight force of this block. So that weight force is the net force acting on the entire system. So let's call this M2, let's call this M1, and this is going to be capital M, the mass of the disk. So the net force of the system is M2G. Let's put G here. And then we need to divide it by the total mass of the system. So that's the mass of the first block plus the mass of the hanging block. And we can't just use this mass. We need to take into account this equation. The inertia of a disk is 1/2 mr squared. Now, for different shapes, this number could vary, so I'm going to put a constant c. So I like to think of it as inertial mass. You could call it something else if you want, but we need that c value to be in this equation for this to work. So that's how you can find the acceleration of the system for this type of system. So let's go ahead and calculate it. So M2 is 10, G is 9.8, M1 is 5, M2 is 10, C for a disk is 1/2, and the mass of the solid disk is 20 kilograms. So 10 times 9.8 is 98, half of 20 is 10, plus another 10, that's 20, plus 5, so this is going to be 25. 98 divided by 25 is 3.92 meters per second squared. So this is the acceleration of the entire system. So let's see if we can get that answer using another process. So how should we do this? Well, we need to indicate all the forces that is acting on the system. So we got the downward weight force, M2G, and there's an upward tension force that slows down the descent of this object. Let's call that T2, the tension force acting on block 2. Now we have T1, which pulls block 1 to the right. Now these two tension forces are acting on the pulley. So if T2 lifts up the object, you can be sure that T2 causes the disk to be pulled in the clockwise direction. And T1 causes the disk to be pulled in the counterclockwise direction, opposite to that value. And so the net torque acting on the disk is the difference between these two values. Now, in another video, I defined a positive torque as a torque that causes counterclockwise rotation. So T1, torque 1 is positive. Well, T1 rather, the tension force that creates that torque is going to be positive. T2, this tension force, will create a negative torque because it will cause the disk to rotate in the clockwise direction, which I assigned earlier as a negative torque value. So the net torque of the system is going to be the positive torque T1 minus the negative torque T2. And the net torque is equal to inertia times alpha, in the same way as net force is mass times acceleration. So the net torque is the inertia times the angular acceleration based on Newton's second law for rotational motion. So that's going to be the difference between T1, or torque 1, minus torque 2. Now I'm going to take a moment to improve this drawing so there is no confusion. So T1 is being directed opposite to this tension. They have to be equal and opposite in direction. And T2 acting on the disk is in this direction. Now T1 is going to create a torque that will cause the disk to spin in the counterclockwise direction. So that torque is positive. And T2 will create, let's see if I can fit it here, a negative torque, which will cause the disk to spin in the clockwise direction, and this is spinning in the counterclockwise direction. Keep in mind, clockwise rotation is negative, counterclockwise rotation is associated with a positive torque. So as we said before, the net torque is going to be the positive torque T1 minus T2. And so net torque is inertia times alpha. Now the inertia of a solid disk is 1/2 times the mass of the disk times r squared. Now linear acceleration is equal to the angular acceleration times r. So angular acceleration is linear acceleration divided by r. So I'm going to replace alpha with a over r. And so that's equal to this stuff on the right side. So now let's cancel r. So what we have left over is 1/2 mRa, which is equal to torque 1. Torque 1 is equal to the tension force times the moment arm, which is the radius of the circle. So that's going to be T1 times r, and torque 2 is going to be T2 times r. So we can divide both sides by r. So now we have 1/2 Ma, which is the difference between the two tension forces. Now the net torque, is it positive or is it negative? What would you say? Now we know the whole system is moving in this direction, which means that the disk has a net torque that causes it to rotate in the clockwise direction, which is associated with a negative torque. So therefore we need to put a negative sign. So now let's save this equation. We're going to get back to it. So I can erase some of the stuff above here because I'm going to need the space soon. So I'm going to rewrite the equation up here. T1 minus T2 is negative 1/2 Ma. Now we need to relate the tension forces to these two masses. So now we need to write expressions for the net force acting on each object. So let's start with the first object, mass 1. The net force acting on mass 1 is equal to this tension force because there's no other forces acting on it, at least in the x direction. So the net force on that block is equal to Ma. So T1 is equal to Ma. So that's the first equation that we can write. Now let's move on to block 2. So the net force acting on block 2, which is associated with the y direction, that's going to be equal to the upward tension force T2 minus the downward weight force M2G. Now keep in mind M2G is negative because it's going in the negative y direction. That's why we have the negative sign. And T is positive because it's going in the positive y direction. Now the net force acting on block 2 is equal to M2 times A, and this is supposed to be M1A. Now because this is moving in the negative y direction, we need to put a negative sign in front of M2A. M1A is moving in a positive x direction, so therefore it requires a positive sign. So now I'm going to take this term, move it to the left side. So therefore, M2G plus M2A is equal to T2. So that's the second equation that we need. So now our next step is to replace T1 with M1A, and then replace T2 with M2G plus M2A. Now there's one small correction that I need to make. That should not be a plus sign, since I have a negative sign right there. So let's put that minus sign. So now let's replace T1 with M1A, and then minus T2, which is this stuff here. So let's put that in parentheses. So that's going to be minus M2G minus M2A. And all of that is equal to negative 1/2 MA. So now let's distribute the negative sign. So this is going to be M1A minus M2G plus M2A, and that's equal to negative 1/2 MA. So I'm going to take this term, move it to the right side so it becomes positive. And then I'm going to take this term, move it to the left side so that becomes positive. So it's going to be M1A plus M2A plus 1/2 capital MA, and that's equal to positive M2G. So now I can factor out A from each of these three terms. So it's going to be A times M1 plus M2 plus 1/2 M, and that's going to be equal to M2G. So I need to divide both sides by this term. So this is my final equation. The acceleration is equal to the downward weight force, which is basically the net force of the system, divided by the total mass of the system, where you have to incorporate the C value, which is 1/2 for a disk. So now let's plug everything in. So M2 is 10, G is 9.8. M1 is 5, M2 is 10 plus 1/2 times the mass of the disk, which is 20. So this is going to be 98 divided by 25, just like before. And that's going to give us the same answer of 3.92 meters per second squared. So that's the acceleration of the whole system. So that's how you could find it. So now you have two ways in which you can come up with this equation.